My turn. For this question, we're going to need to use a combination of trigonometry and Pythagoras' theorem to help us find a missing value. In this case, we're looking for the angle that has been highlighted in yellow. So to start off with, there's a couple of approaches here, but what I'm going to start off with, similarly to how we've tackled Pythagoras in 3D, I'm going to look for this length here. To do that, I'm going to consider the base first of all. My base consists of a rectangle with the dimensions of 4.4 and 7.4, and I'm looking for that diagonal, and I'm going to label it N. As you can now see, I've got that right angle triangle created by this cuboid and the right angle. So I'm going to use Pythagoras. So I'm going to get n squared is equal to 4.4 squared add 7.4 squared. That is going to give me a total for n squared of 74.12. I'm then going to square root that to find my value of n, which is 8.6. And it carries on. To two decimal places, you're going to get 8.61 centimetres. If you are going to carry on with the decimal, obviously using that answer function, you will come up with the same answer. It may just be that if you are rounding earlier on, just be really careful that you are rounding accurately. So now I found that base. I can now tackle this pink triangle. So I'm going to redraw it here just for clarity. I've got my angle, I've got my base now, which is 8.6. I'm going to call it 8.61 for now. And the height of this triangle is going to be the same as the height of the cuboid, this side AD, which is the same as side BC, which has been labelled as 4.9. So I've got a height of 4.9. And then I go about using trigonometry. So first of all, I've got to eliminate what I know, what I want, and what I have. So first of all, the hypotenuse is not available to us. We do not want it. We do not care about it. So that immediately takes out so and cat or our cos and sine functions. So obviously I'm going to be using this tan function on my calculator. So we know the tan of the angle, I'm going to call it theta, is going to be our opposite over our adjacent. Opposite and adjacent refer to the lengths around the angle. So what I'm now going to do is rearrange this slightly to get theta is equal to the tan, the inverse tan function of the opposite over the adjacent. Now I go to my triangle, opposite is there, the adjacent is the one that's touching that isn't a hypotenuse, so it would be this one here. So my equation is now going to look something like this. I'm going to get tan to the minus 1 of 4.9 over 8.61, or the long decimal. If you have that answer function, you can use it here. That is going to give me a final answer of 29.65 degrees, or to the nearest whole number, 30 degrees. Be careful when you're rounding to which degree of accuracy. So that's two decimal places, and that's, I'm just going to put WN for whole number there. Careful, read the question carefully, see what it asks for. You might prefer to round to one whole number here, to one decimal place or two decimal places, or significant figures. If it doesn't give you a degree of accuracy, state what you've used, state what you've decided to jot down. Make sure it is a sensible degree of accuracy, though. Don't go choosing one significant figure if it is a very large number, as it can take out a lot of our accuracy there. So pause the video and have a go at the your turn question. Your turn. So once again, we're going to start by considering that base, because we're first of all going to look for that length GD. So once again, I end up with a rectangle, and this time its dimensions are 4.5 and 7.9. I'm going to go about using Pythagoras. Again, I'm going to label this diagonal n just to ease my notation. So I'm going to get n squared is equal to 4.5 squared add 7.9 squared. That's going to give me a total for n squared of 82.66. When I square root, then I'm going to get n is equal to 9.09. That is to 2 decimal places. Again, if you're using that answer function, you could just put some ellipses there. So now we are looking at that pink triangle once again to find this missing angle. So I once again have a triangle with theta. The height is 4.9 as stated, as once again it should be the same as the total height of the cuboid, and our base now is 9.09. So once again, SOHCAHTOA, I have to decide what I have, what I need, and how to get there. I don't care about the length of the hypotenuse, I don't have it. So immediately I'm going to be looking to use my tan function. Again, because I'm looking for the angle, I know it's going to be the inverse tan function, so it's going to be tan to the -1. Theta being that unknown for the angle. Opposite over adjacent, so the 4.9 over the adjacent, which is that base there of 9.09, or obviously the slightly longer decimal. Once you type this into your calculator, this is going to give you an answer of 28.32 degrees to 2 decimal places, or to the nearest whole number, 28 degrees. Use these examples to have a go at the next set of questions.